Hello, welcome back. Let's continue with our textbook. This video is about our chapter 6, and that starts our part 3, which is the basic area design. So, chapter 6 of our textbook, which is um, the design and drafting for architecture and construction. Chapter 6 is about environmental design factors. So here there are a few objectives. We'll learn about the LEED, which is the leadership in energy and environmental design. We'll learn the basics of environmental planning. Then we'll take a look at the methods of sun protection. And we'll learn how to orient the house on the lot to take best advantage of solar energy and features of the lot. And we'll take a look at different ergonomical design features and the ways to prevent pollution. So a few terms that you need to know: active solar design systems, baffle, deciduous tree, earth sheltered homes, ecological planning, ergonomics, land integrity, LEED, noise abatement, orientation overhang, and passive solar design systems. So let's first of all talk about the building orientation. That's something that you need to take care of very early in the design phases. So a building must be positioned to maximize desirable features and minimize the negative aspects of the environment. So let's say you design something in a cold climate. You really would like to get to maximize the heat gain and to keep the house warm at all times during the winter months. Or if you design in a hot and humid climate, you really want to use the maximum of the passive cooling of the breeze. So that's something that you really cannot change later in your design, because the building orientation is something that you need to do in advance. You need to really just plan it, coordinate with the zoning department, with the building department, and technically, like, yes, you can demolish the house and build a new one, but that's not what we're talking about here. So, today, actually, we unfortunately supply our energy with the fossil fuels, and we know that they are not indefinite. So, we need to apply energy efficient principles in building design to control indoor environments. And mechanical or electrical devices can be added to control the sun's energy. So those systems are called active solar design systems. But the carefully designed buildings can use the power of the sun without mechanical devices and still provide much environmental control. And these systems are called passive solar design systems. So they only use the design features and the orientation of the building, and then that is used to gain and control the sun's energy. So please go back to the textbook. You will see the basis of seasonal solar planning. This is a beautiful diagram and how that affects the house. And you will see the summer and winter sun paths. That's something what architects always do when they just design a house from scratch, from ground up. So you know that walls, floors, and furniture can absorb and store heat from the sun. So this heat is naturally released when the temperature is cooler. So during the winter months, we would like to gain that heat, if that's the house located in the cold climate. So open interiors and high ceilings encourage ventilation and cooler temperatures, and low ceilings and closed floor plans tend to increase temperatures. So, and sunshine, we know that it should be avoidable in the kitchen and dining areas during the early morning and should reach the living room by afternoon. So when we plan our space, we should place kitchen and dining areas in the south or on the east side of the house. That's how we usually do when we plan things. And then the north side is the most appropriate side for placing sleeping areas. It's a little cooler. It provides the greatest darkness in the morning and evening. And also northern light is consistent and diffused and has little glare. So that's kind of like, the main principles of the orientation. Of course, there are other things that we need to consider. There are different theories how you should locate spaces inside the house, feng shui and others. But these are kind of like the main principles how to orient the spaces inside your building. When we talk about the overhangs and baffles, so the baffles are the shields, and they should be designed to allow the maximum amount of sunlight and heat to penetrate the inside of a building in winter. And conversely, the maximum amount of sun and heat should be shielded from entering the interior during a summer midday. So again, there are tons of beautiful diagrams and sections, and you can see how the overhang is designed, how to control seasonal sun exposure, and also you can use that to calculate south side roof overhang. Typically, when we design the overhang for our southern side, you use the horizontal overhang. And when you want to protect the windows from eastern and western exposure, you do the vertical louvers. So, and you can rotate them depending on where the sun is coming from. So, also the site is always very unique. So there are no two sites that are exactly the same. And we can maximize that. We can use it to our advantage. And before orienting and designing a structure, you need to consider specific physical characteristics of the site, such as a hill, valley, fence, or whatever buildings are around, any adjacent structures, trees, and other water bodies. So we really would like to maximize the site and make sure that we use that to our advantage. So large bodies of water may also affect air temperature and air movements. And when you surround pavement areas and buildings, um, actually uh, surrounding pavement areas and buildings can raise or lower temperatures because concrete and asphalt collect and store the heat, the sun's heat. So there are very interesting concepts here, and one of them is the earth sheltered home. So these types of homes are designed to be partially covered with earth, and they're getting actually more and more popular. So they were kind of like vernacular structures back in the day, but now um, actually it's very popular just because the temperature there is consistent throughout the year. And then soil is an important consideration for designers of earth-sheltered buildings. Soil used to cover roofs and walls must be carefully selected to avoid frost heave, excessive swelling, and runoff tendencies. So that soil, yes, it is natural, but it should be selected for our design. And the best site location for an earth sheltered home is on a gentle downward slope, and the exposed walls should make maximum of glass to capture as much light and heat as possible. So that's very, very interesting, and I would really recommend to take a look at that and how we can design that. So Other non-conventional building types include rammed earth, adobe block, and we can see that in the Midwest, New Mexico, and other states. Then we can see the straw bale construction that is gaining popularity. So rammed earth construction uses a mixture of damp soil that is rammed into a compacted form to a wall of sedimentary rock. And also adobe uses a mixture of sand, clay, and straw to create blocks that are stacked in layers to create solid masonry walls. And straw bale walls are covered with stucco on the exterior and plaster for the interior. So that is very interesting. It's not new, but it's gaining more and more popularity. Let's talk a little bit about the trees. So deciduous trees maximize summer cooling and winter heating. They provide shade in the summer and then lose their leaves in winter. So, and dense coniferous or evergreen trees and shrubs are most effective for blocking or redirecting north or northwest storm winds to help protect a building during all seasons. So, a few beautiful plans here. Please review the textbook. I cannot just say it. I just really recommend to go through the textbook first and then watch my videos just to kind of like recap on the material because I'm not sharing the screen for, due to the copyright reasons, but I just want you to know what's going on there and what uh, is in the chapters. So when we control the wind, that's one of the main functions of effective building orientation. And existing indoor heat can be lost very rapidly when cold air is forced into buildings through crevices, usually around doors and windows. And heat also escapes by wind chill loss through walls, windows, roofs, and foundations. So that's the thermal bridge where there's no insulation and that is connected to the exterior temperature. So the direction and velocity of prevailing winds also affect the temperature, ventilation, life loads, and uplift on the structure. So we really need to consider wind when we design the buildings. There are a few wind patterns and they're relatively common. So desirable summer breezes usually flow from one direction and winter winds from the opposite direction. And cool air will always move to replace rising warm air. So cool air is always on the bottom and hot air rises. We know this principle already. So when we talk about the wind effects in urban planning, when we have isolated clusters of buildings, care must be taken to avoid the creation of turbulent wind eddies. So this effect is caused by high velocity winds striking the upper floors of high-rise buildings and being forced downward and back against lower buildings, creating turbulence on the surface. So we need to plan for that. We definitely want to know all the effects and how to deal with that, what to incorporate, what design features to incorporate to maximize or minimize that effect. So in urban situations, the Venturi effect also complicates wind control. So the Venturi or wind tunnel effect is created as large amounts of moving air are forced into narrow openings. And the reduced area through which the wind must pass creates a partial vacuum, and the air picks up speed as it is pulled through the opening. So the Venturi effect can be partially controlled by avoiding the alignment of streets or buildings with the direction of prevailing winds. So here also another great thing to talk about is the human dimensions, and they're critical in planning the size and positions of all the FF&E or furnishing fixtures and equipment. Also, traffic areas, door openings, windows are all based on human dimensions. So please make sure that you review that and you want to see the Vitruvian man for sure. And also, you need to understand the ergonomic planning. So that also applies to persons with physical disabilities and such as those with hearing, speech, visual, or mobility impairment. So please make sure that you design for everybody. Uh, Also, architectural design involves the safe arrangement of outdoor traffic areas, and the increasing use of technology is creating another concern. So, before the design process is begun, an assessment must be made to determine what special technology needs are anticipated. So whether we need smart buildings or we need some type of like high or low voltage circuits, or we need some, computer equipment or like some radio waves, whatever we need for building to function, we need to plan that in advance. So when we talk about ecology and the environment, what we need to know here in the field of architecture, engineering, and construction, the term environment is used to describe the physical conditions that influence the life of organisms. And ecology, we know that that is the science that describes the relationship between all living organisms and their environment. So here, what we need to know about the good ecological planning is actually that it means protecting or improving the environment without sacrificing the qualities of good design. And natural forces continually work to maintain a balance between all elements of the environment. And this minimizes the dominance of one element over another. So humans need to kind of use that and use smart growth practices that will affect the community planning. So just kind of like looking at the nature and making sure that we mimic that and we create it smartly. So when we talk about the land integrity, what we mean here. So design and construction professionals can prevent, correct, or avoid these problems in many ways. So we can reserve open green spaces in site development projects or minimize the removal of trees and major vegetation, then recycle topsoil that is removed during the building process, and minimize recontouring of natural land slopes, which results in the tree root destruction. So also, what else we need to take care of here is the air quality. And we know that the two types of air pollutants are those that originate outside a building or site and those that originate inside a building or the site. So also all the building materials release gases or fine particles into the air, and they're the primary cause of indoor pollution. So we know that they are called the cause the sick building syndrome because the pollutants found inside the structure include toxic gases such as carbon monoxide and nitrous dioxide that are derived from unvented gas heaters, leaking chimneys, and also gas stoves, and so on. So when the building occupants often increase their own pollutants by adding tobacco smoke or aerosol sprays and cleaning agents, so that also contributes to the bad interior environment. And Also, when we talk about the water quality, what we need to know here, the quality of water entering and surrounding a building is often compromised by many factors. So, water pollution is often caused by the dumping or leakage of sewage, industrial chemicals, and agricultural waste into oceans, lakes, rivers, and streams. So, when the construction is happening and it's a lead project, we need to do the construction activity pollution prevention plan, and then we need to take care of that during the construction. So, also, what else is important in this chapter that we need to know is the noise abatement. Unwanted sound is called noise. So, when sound is extremely offensive, it's called noise pollution. The effects of sound depend on their time, location, duration, source, and listener control. So undesirable sounds should be controlled at their source. And we know that sound levels are measured in decibels, and exposure to excessive decibel levels over 80 or to even moderate levels over 60 for long periods creates stress and can result in hearing loss even. So some of the noise abatement methods designers can use to keep noise at acceptable levels include the following. So we can orient floor plans to locate quiet areas away from outside noise sources. Then we can use foliage to provide sound barriers and buffers. Then add insulation and thickness to interior walls that have noise sources. Use double or triple glazed windows. And then we can maximize the use of sound absorbent materials such as carpets, drapes, upholstery, and tapestries in our design. So, also, what else is important here is the fire protection. So, all materials, solids, liquids, or gases will burn, explode, or become seriously damaged if exposed to a sufficiently high heat source, open flame, or spark. So, and elements with the greatest combustibility include solids such as wood and wood products, liquids such as gasoline or kerosene, and gases such as propane and natural gas. Architectural designers must create buildings design that separate heat, flame, and spark sources from flammable materials. And there are a few measures how to do that. It depends on the type of structure, the type of construction, and also what else is required in that particular jurisdiction. There are also electrical and electronic hazards. In addition to the danger of electrical shock from faulty electrical products or connections, continuous exposure to excessive amount of electromagnetic force or EMFs is considered unsafe. So living in proximity to high power voltage lines, faulty microwave appliances, and concentrations of television cables and wiring may pose a threat to occupants' health. So we need to make sure that we don't do that. Also, this chapter highlights some of the features of LEED or the leadership in energy and environmental design. And that was created by the US Green Building Council. And those are the standards that encourage architects, engineers, and construction firms to produce more cost-effective, energy-efficient, environmentally friendly, and sustainable structures. So there are a few things that we need to know about LEED. So the use of shade trees over paved areas, then we need to also incorporate light colored walkways that will reflect the sun. The roof systems with highly reflective qualities. Then the building needs to be designed to improve energy efficiency.
The heating and cooling equipment installed in the building need to minimize or eliminate the emission of compounds that contribute to ozone depletion. Um, the VOC, or volatile organic compounds, we already spoke about them. Those are the gases or particles that are released from all the building materials and finishes. So also, there are a few things that we need to know when we design building according to the LEED principles. There are prerequisites and there are credits. And there are design credits and there are construction credits that we need to know and learn about if we want to actually submit that documentation to achieve the LEED certification. And there are a few levels: LEED certified, silver, gold, and platinum. So, and they depend on the number of points that the building can get for being compliant with all the requirements. So that is basically it for our chapter 6. If you want to learn more about LEED, I have a video that covers the exam requirements. That's for LEED Green Associate. And I'm putting together a course for the LEED AP, or accredited professional, with the specialties. So let me know if you are interested in that, and I will see you in my next video. Goodbye.